We've already been introduced to this guy, the rectangular coordinate system, the graph. Now what we're going to be doing is looking at pictures, graphs of, visual displays of equations. Typically equations with two variables, like this guy right here. You can talk about this guy in a couple of ways. You can say, hey, there's an equation in two variables. Or there's an equation that talks about y in terms of x. Or there is a linear equation. Linear basically meaning its degree, which you probably remember the highest exponent is 1. Linear equation, the highest exponent is 1. That's a linear equation. A linear equation is going to graph into a
line.
Yeah, linear graphs into a line. Okay, into a line. You look at linear, the name of what it graphs into is right there in the middle of it. It's a line. Hey, how are you going to get some points that determine what this line looks like? That's what you're going to do. You've probably done this before. Make your little grid. Keep the x and the y in the proper order. These are, after all, ordered pairs. Hey, and here's a good question. Are you going to pick x's, you think, or are you going to pick y's?
X's.
That's what you're going to do. You're going to go to the variable that's the most mixed up, the most complex, in the midst of the biggest mess. That's what you're going to pick. Otherwise, you're going to end up with stuff that's not whole numbers. You pick x's, you got whole numbers. You pick a whole number x, you got whole number y. So let's pick an x. What's a good choice for x?
1.
1 is nice. 2 times 1, that's what we do. We substitute. If x is 1, then this is 2 times 1, that's 2, plus 3 is 5. What else you like?
2.
2. And again, make it easy on yourself. Don't pick pi over 4 or 3.7, something like that. Pick a reasonable term. 3 times 2 is 4, plus 3 is 7. Hey, how many points does it take to figure out what a line looks like? 2. Why do we pick 3? Yeah, so we can sleep well at night. To make sure. Just to give us some reassurance that, those first 2 must have been correct because this one lines up with them. What else you want to pick?
3.
You like 0? Okay. 3 is good, 0 is 3. 0 is good. 2 times 0, that's 0 plus 3 is 3. 3 is good, that's 6 plus 3 is 9. Hey, a little overkill here with 4 points, but 0, 1, 2, 3, 1, 5, 2, 7, 3, 9. And I'm so delighted and reassured because all these points are collinear. That means they're on the same line. And there's a graph of the line y equals 2x plus 3. Hey, so you got a principle here. If you have an expression in two variables, like y equals 2x plus 3, you're going to pick the variable that's in the most disorganized or complex state, in this case the x, and you're going to find some y's, and you're going to graph them. Example number 1, a linear equation. How about if it's not linear? How about if the highest exponent, the degree is something other than 1, like this? If an equation of degree 1 is called linear, what is an equation of degree 2 called? Quadratic. You heard that before? Of course you have. It's got a formula and everything. Quadratic is basically talking about a second degree equation. This is quadratic. And if a linear equation translates to a line, what does a quadratic equation translate to? Very good, a parabola. Y'all have encountered that before? U-shape, parabola. Hey, we're going to do exactly the same thing. What are you going to pick, x's or y? Absolutely, you're going to pick x's. They're in the messed up part of the equation. Y is all pure and simple here. X is the one that's going to give me some problems, so I'm going to pick x's. What do you like for x? Let's start with 0. 0 squared, that's easy, minus 5, negative 5. What else you like?
1.
Okay, 1 squared is 1, minus 5, negative 4. 2 is 4, minus 5, negative 1. So one more on 3. 3 squared is 9, minus 5. I got 4 points. 4 points was sure good enough to do a line. Let's see if this is good enough to do this. 0, negative 5. 1, negative 4. 2, negative 1. 3, 1. And I see, if I try to use my ruler, that won't work. It's a curve, and I follow the curve. And there's a graph of my parabola, right? It's kind of like an extreme sport skateboard ramp. Is that it? Is that the graph of?
That's half.
That's half.
What do I need to do?
Finish on the side.
That's right. I need to do some negative x's to figure out what this thing looks like over here. And we'll discover, let's see, negative 1 is x. What's negative 1 squared? 1. Still 1. Minus 5 is still negative 4. Negative 2 squared is, again, 4. Negative 4. Negative 3 is positive 9. Minus 5 is 4. So I get what you said, a symmetric representation here. Okay. And I have a good understanding of the whole picture of my graph. It is a U-shaped. This guy goes, has arrows on the end, implying it just keeps going up forever and ever. Hey, any question about that? If I have an equation, I look to the more complex side, pick some variables there, and find the other variable by substitution. Plot those points, see what the thing looks like. All right, something I want you to notice while we're looking at this parabola. A word you already used. What was the word you used? Somebody used it. Symmetric. Imagine that you're not in a math class, which some of you have been doing since even you got here. But for the rest of you, imagine that you're not in a math class. The word symmetric means what out there in the world? What do you think? Identical on both sides.
Semi means half, doesn't it?
Semi means half. Okay, you got halves.
Symmetric, yeah, 2 halves.
Okay, 2 halves. Everybody else, symmetric? What do you think of? You artsy folks, what do y'all think of? Exactly the same on both sides.
Or mirror.
Mirror image, good way to think about it. Yeah. You know, when you went, some of you went to the Palace of Versailles outside of Paris this summer. Remember that? Palace of Versailles. And you went down the main drive, there were symmetric trees on both sides so that you turn one way, you turn the other, you think you're looking at a mirror image of what you see on one side. A lot of architecture and art is symmetrical. This guy is symmetrical. And it is symmetrical in respect to a particular line. What line